Alright, this video is going to introduce you to Java math, Java arithmetic. One of the key things about this is that Java math is sometimes different than what we've learned in our regular math, and sometimes it's the same. So sometimes you're going to have to just forget about what you learned previously in regular math and see how the compiler, how Java handles different math situations. So the first thing is the arithmetic operators would be the addition operator, the subtraction operator, the multiplication operator, which is the asterisk, and then you have the division operator, which is the /, and then you have a thing that we'll mention later, so you don't have to write down modulus yet, but this is the percent sign is actually called the modulus operator. And so when the compiler sees the percent sign associated with two numbers, numeric values, it will think of it as a modulus operator, and we'll see what that does later. Then there's the word operands, which we've already introduced in this class, but operands is the expressions on both sides of any arithmetic operator. Right, so this is the expression that's on both sides of any arithmetic operator. All right, so in the examples below here, the 8 and 2 are operands in every situation in this case. So you have the 8 and the 2 are with the plus sign, and so with the addition operator. So this is an operand, that's an operand, here's an operand, because they're on both sides of the arithmetic operator. Now, in regular math, we would call these two things addends. Not so in Java. We can just get to call them operands. Here you would have the minuend and the subtrahend, but we don't do that in Java. We just call them operands. Then you might have the dividend and the divisor, but not so in Java math. We call them operands, and so that's how it works, and makes it easier. If we go on, we're going to go then the result of a calculation in Java depends on the data types of the operands. All right, so whatever the data types are of the two operands, the expressions on both sides of the operator, those data types are going to determine the data type of the result. And we're going to practice that. So if both operands are ints, the result is going to be an int. So that's pretty easy. I think that's pretty intuitive, as they would say. And if both operands are doubles, 3b here, the result is a double. Though that's easy. Now, where it gets a little bit more complicated, but really not that bad, is that if the data types of the two operands are different, if they're different, not the same, the data type of the result is going to be the data type of the operand that is representing the how do I want to say that here? Oops, I think what I did, I got to put a pause on this. Okay, so the data type of the result is the data type of the operand representing the larger memory size. The larger memory size. So if you remember, when we introduced data types, we said, okay, well, the ints are reserving a certain a cell that will be able to store a certain amount, and so it might be this much for an int. But when it reserves a double, it actually reserves an area that can hold more data in it, and so it has to do with size. So here's an example. You have a double is the largest, as we said, and the next one is a float. Now, float is a decimal And so you have doubles and floats that are both what they call floating point data types. So they both have to do with decimals. And so if you have a number like 7.2 versus a 7.178, they both round to 7.2, but which one is the more accurate, more precise? And you would say, well, it's the one that has the most decimals, most number of decimals. So this has 3 decimal places. This only has 1. So therefore, this one is more accurate. So when you have a float is going to have fewer decimals. It can store fewer decimal places than a double. So that double is the largest. The float is more precise than a float. Now you have a long as an integer type. Int is, of course, integer, and the short is a shorter integer type in size to the int, and then the byte is the smallest one. So, but all we're doing is we're basically using ints and doubles. So that's all. You just need to remember that the double is larger than the int. And so as we move on, then the data types of the 2 operands are both ints. Then, as we said up here, the result is going to be an int, so you would type or write an int in here. Now, if they're both doubles, and we already mentioned that here, the result is going to be a double. Now, you have an int and a double. Well, it's the data type. The data type of the result is going to be the data type of the operand representing the larger memory size. And so we said that doubles are larger than ints. Therefore, the result has to be a double because it has the larger memory size. All right, so that's how that goes. And now we're going to get to see some of this in action here as we move on to the very fun division. Now, division is going to present some issues. The adding and subtracting, things like that, multiplication, follow, for the most part, are going to follow regular math much more. But the division is going to cause issues. And so we are going to look at this. So now, a 14 divided by 3. Now, based on the concepts, and maybe I should scroll up so we can see that. Well, we have it right here. That's close enough. Based on the concept, if you have 2 ints, or you have 2 doubles, or if they're both different, doesn't matter the sign. The sign doesn't have to do with anything as far as the data type of the result. So an int divided by an int, that's this right here, has to be an int. So you can write int in here. In this one, the double divided by double. So if they're both doubles, then the response or the result has to be a double. And then, if they're different, so here's an int, here's a double, the result is the one with the larger size. Doubles can handle more size, so this result has to be a double. All right, now here's some sayings that might help, and then we're going to practice it here. It's the sayings that might help you, and this is something I got when I was tutoring somebody, and it just came up with it, and I said, this is what I need to present in class. So if both operands are ints, this is especially in relationship to division, is when you think of when you saw 14.3, I think probably all of you thought, okay, that's going to be a decimal because 3 doesn't go into 14 even. And so what you're doing is you're thinking like a calculator. That's how students do things. So I was thinking, well, you know what? Let's use that to our advantage. If you think like a calculator, keep doing that. Keep thinking like a calculator. And so here's a little saying. If both operands are ints, then use the calculator. Drop, actually I think I put it like that, and then drop the decimal. use the calculator, drop the decimal. And so we're going to pull up a calculator here, and we're going to go 14 divided by 3, so 1, 4, divided by 3, and we get 4.666, etc., 7. Okay, so we get 4.6667, let's say. And if you can remember this, from now on, if I don't give instructions on where to round something to, round a decimal to, just go 4 places and stop. If I don't say how many to do. So just go 4 places and then stop. So drop the decimal. So you have 4.67, and then what we're going to do is we are going to drop the decimal. And so an int divided by an int, it gets to that int by dropping the decimal. And so you're left with a 4. So we're not rounding it up to 5. We're dropping the decimal. And so that's why then 14 divided by 3 is actually 4. Now, if one or both operands are doubles, then what you do is, let's do this. I probably should have gone like this. It's not working. Okay, so if one or both are doubles, so all you need is one of the operands to be a double, then the result has to be double. So you use the calculator, and then instead of dropping the decimal, you keep the decimal. So in this example up here, if we take 14.0 and divide it by 3.0, we would do the calculator, and so we would get that 4.66667, and then you keep the decimal. So the result would be 4.667. So you see the difference there. That's how it goes. And so you can either do well, actually, I've already done these. So the calculator says 4.6667, and we drop the decimal, and it becomes 4. Okay, I kind of made a mess of this. And so, oh, that's really weird. Okay, I see what I did. Okay, so 4.667, and then you drop the decimal, and you end up with a 4. This one, it's the same thing. It's 4.6667. And then you keep the decimal, so it stays the same. And then the next one, because at least one of them is decimal, you still keep the decimal. So the calculator says this, then keep it. That's how it works. All right, let's move on. So here's some division practice. So I would encourage you to go ahead and do this, pause the video, do this, and then come back to see the answers. Okay, so hopefully you did these problems first. And so now these are not the answers, so be careful, these are not the answers. These are the calculator. So we said the first step in every situation is use the calculator or think like a calculator, which is normal to do. So the 22 divided by 4.6 calculator gives you this. Since we have a double in there, keep the decimal. So this is the answer. 22 divided by 5 calculator gives you 4.4. But they're both ints, so you drop the decimal. So the answer is 4. All right, then, so you were not rounding, but we're just dropping the decimal. Here, if you do the calculator, you get 6, but this is supposed to be a double. So it says keep the decimal. Well, there is no decimal, but if you were to add a decimal, then it won't change the value of it, so it's 0.0. So this is 6.0, not 6. This one is 2, number 2 here. The first one is 2.2857. They're both ints, so you drop the decimal. It's just 2, because it has to be an int. This one is 25 divided by 7, 25.0. Has a double in it, so keep the decimal. This one, 3 divided by 10, has to be an int because both operands are ints, so you drop the decimal. So it's just 0. So according to Java Math, the compiler will get 3 divided by 10, we'll say it's 0. Number 3, here is a decimal, or a double, so this has to be a double, so keep the decimal. These are 2 ints, so we drop the decimal. And notice we don't round it up to 9. We drop the decimal, not round. And right, so we have a double here, so keep the decimal. That's how it works. If you can remember that, you're going to be great as far as the Java Math goes. All right, let's move on. Number 5. A modulus operator is also called the remainder operator. And it is, so what it's looking for is the remainder of a division problem, which we'll talk about here in a second. So 7% sine 3 is read the following way. It's read as 7 modulus 3. Or you can read it as 7 mod 3. Now, I usually will say the modulus, but some people will say 7 mod 3, which is actually easier. 7 modulus 3, 7 mod 3. So then 7 modulus 3 returns the remainder. Oh, I shouldn't be doing that. Returns the remainder when 7 is divided by 3. So 7 modulus 3 returns the remainder when 7 is divided by 3. And so one of the things that is really good to know is how to do division. Oh man, I can't believe it did that. So 7 divided by 3 is like what you learned in elementary school. So you go 3 into 7 goes twice. And then 2 times 3 is 6. Subtract, you have a 1. So back in the day, before you did fractions, you learned this as 2 remainder 1. There's 1 left over. And so the result then is the modulus operator is only looking for the remainder. So 7 modulus 3 is 1. So go ahead and practice these problems, and then pause the video and then come back and get the answers after you're done. Okay, so hopefully you got those done. And so as we look at this, 14 divided by 5. 5 goes into 14 2 times. So 2 with a 4 left over. And so this is 4. It's because it's the remainder. 22 divided by 6 is 3. And that 3 makes it 18. And then so there's still 4 more to go. So it's 4. The remainder is 4. And so the modulus is asking for the 4. 7 modulus 10. Okay, so this one is interesting. So if you take 7 divided by 10, all right, so you go 10 goes into 7 0 times. Now we're not dealing with decimals because we're dealing with 2 ints. So we go 0 times 10, which is 0. We subtract, we have 7. So we have 0 remainder 7. Just like we did up here. We did the same exact thing. The weird thing is, though, the whole number is a 0. And so the 7 modulus 7 is 7. Okay, 12 divided by 3 is 4 with nothing left over. So we have a 0. 35 modulus 6, 35 divided by 6 is 5 remainder 5. This was not a good problem because you only it's the 5 though. It's really this 5. Doesn't matter though. Okay, so 4 modulus 5. All right, so we have 4 divided by 5 goes in 0 times. And so 0 times 5 is 0. Subtract and you get 4. So 4 is what this is going to be, because that's the remainder. 42 divided by 6 is 7, remainder 0. 95 modulus 4. Now here's how you can do modulus. Let's say you do this in the calculator, because this you might end up doing some of these by calculator, but you got to know what to do with it. And so if we were then to take 95 and divide it by 4, notice when we divide, we just drop the decimal, so it's just 23. So this is going to be 23. Well, you got to figure out what the remainder is. Well, in numbers like this, you can't tell by the decimal here. So what you got to do is you got to take that 23 and you have to multiply it by 4. Which you have 92. So you can see that we still have 3 left to go. So now there is a way to deal with this, to talk about it and illustrate it in a different way, which may not work on the video, so I'm just going to leave it at this. So this is just going to be 3. Alright, so let's go on and talk about operator precedence. And that is, this is the last thing we'll do. Operator precedence is the order in which operators are used. It's the order in which operators are used. Now this is another one of those things that's actually like what you already have learned in regular math. And so you start out with the parentheses, so you think of it as a PEMDAS, which is a lot of people do that. But here's the thing though, PEMDAS goes like this: parentheses, exponents, and then PEM is M and D on the same level. Don't put them on separate levels. And in this case, the modulus will also be on that level. And then you have addition. It's not subtraction below it, but it's subtraction next to it. And so they're on the same level. So this is multiplication, division, modulus from left to right. And then this is also addition, subtraction would be from left to right. So we'll illustrate that now. So you have division, modulus, and multiplication. Those are all on the same level. So you don't do multiplication first, then division and modulus. You do what you see from left to right. So the first thing on the left is division. So 25 divided by 3. 3 goes into 25 8 times. And then you drop the decimal. So now you have 8 now. 8 modulus 6. Because we're going from left to right. 8 modulus 6. Well, 6 goes into 8 one time and has 2 left over. So this becomes 2. And then you have 2 times 3. So it's 6. You're going from left to right. Now we go down here. Students in my algebra classes, they would go 14 minus 10. Because it's really easy just to add those two together. It looks like it's made to do that, but it's not, because we do the operator on the left is subtraction, so this is 6 plus 2. So the result is not 4, it is 8. All right, so let's see, where are we at here? So we have these examples that we just did. And now you have all this practice. So these are the practice, or these are the problems you do for homework on pages 9 and 10 of your notes, and that'll cover it for the Intro to Java Math.